basic elements are already discussed, and we need to look at outputs that can be generated through GIS. There are a few generic questions. Elaborations will follow. Spatial data deals with the location, and GIS address questions concerning the what and where of data. The illustration shows a simple map marked on its edges with latitude and longitude ticks within bracket small marks representing coordinate values in degrees. On the map, there are several features, two types of lines like paved and unpaved roads, and three shapes X, Y and Z, which might be in agriculture areas or inhabited areas. The first question demands a coordinate system. Where is future X? Is answered by making horizontal and vertical coordinate points and answering according to the given system. 3 degrees south and 12 degrees east. On the flip side of the question, the location might be given and the feature is to be identified. The location asked is 5 degrees south and 11 degrees east, which when followed to where they cross on the map arrive at future Y. Do you follow? We want to derive Y through a stage of queries. Location is the fundamental characteristics of spatial data, and GIS considers positions directly, that is site, and indirectly, that is situation. It gives the site a site specific place in terms of coordinate system and the situation, that is relative position using the surroundings. Location is a principal aspect of GIS data. Once you have arrived at locations, then you have to measure. Measurements is relatively easy in GIS, and several types of spatial measurement analysis can be achieved, typically using automatic or built-in functions of the software. These are shown in the top portion of the illustration. Distance. Measuring the length from one point to another usually requires one definition of the points, that is pointing at the beginning and end. Most GIS give real world distance such as kilometers. Second, perimeter. Getting the distance around features may be very few cases, often requiring only selection of the item and reading the value from the database. Third, area and site. Like perimeter, GIS can automatically calculate and store the spatial extent of each feature. Other types of spatial measurements and relationships may be available. These deal with neighborhood characteristics and distance. Three of the most common are presented in the illustration. Fourth, adjacency or contiguity. What is the next to or near a given feature or category of features? In the illustration, feature B is adjacent to A and C is adjacent to B, but C is not adjacent to A. These features could be almost any type of data found on the map. Fifth, connectivity. Physical connection is an important spatial characteristic for many applications. What is actually connected to features can be calculated. In the illustration, B is connected to A, but C is not connected to anything. Sixth, proximity. As in adjacency, distance is an important spatial factor of the position of features. The minimum distance that constitutes proximity, that is spatial association or nearness, can be defined. Therefore, features within certain distance and positions are calculated. In the illustration, the distance from C has been set at 2 km and only feature B has the required proximity.